Hi, my name is Sebastian Dillanella, and this is my hazard research project on the 1751 Chilean Concepción earthquakes and tsunamis. This topic was very close to my heart because growing up I would always watch the news with my parents in the morning because after they saw me off to school, it seemed like every other year, at least once or twice, the news anchors would report Chile or Haiti had been hit once again with magnitude 7 and up earthquakes, along with tsunamis, and then an array of images and videos would play showing the aftermath of the disasters. And at the time, I thought that those countries just had a lot of bad luck, but a lot more factors played a role into why these countries kept getting hit as often and as hard as they would. So a little context on the 1751 Chilean Conception earthquakes and tsunamis. Oh. The 1751 Conception earthquake was one of the strongest and one of the most devastating record quakes to have ever been recorded in Chilean history. The disaster hit the cities of Concepcion, Chilean, Cauquenes, Corico, and Catalca. The city of Concepcion had already been hit by several earthquakes. On this occasion, the city was still in process of recovering from the earthquake and tsunami that had completely destroyed the city in 1730. Hours before the earthquake, on the night of May 23, there were several tremors. This had caused some Concepcion residents accustomed to the earthquakes to prepare for the worst. The disaster was composed of two parts: the earthquake itself, a series of tsunamis 10 to 40 minutes short after, and the earthquake began around 1 o'clock in the morning. According to one chronicle of the resident of Valesperoso and another resident of Concepcion, the quake lasted about 6 minutes. During the earthquake and the subsequent tsunami, all of the buildings in the city of Concepcion were destroyed. The records indicate that the earthquake was so intense that the residents could not remain standing. The earthquake was felt in the rest of the Chilean Central Valley, but with less intensity. One of the most affected cities near Concepcion was Chilean, where the entire city was destroyed and the river changed its course, ending up nearly 15 blocks from its original location. In Santiago, the tower of the cathedral was destroyed by the tremor, although no other major damage was reported in the rest of the city. Between 105 and 145, the sea receded more than 1 kilometer, and then 3 to 5 tsunami waves struck land. The height and force of each wave increased, and the last was the most disastrous. The tsunami also destroyed new settlement at the Juan Fernandez Islands, where 35 people died, including the first governor, Navarro Santella, and his wife. Pretty sad stuff. So the tectonic setting of the chosen region. So Chile is what many seismologists know as a place where three tectonic plate boundaries meet. Here, three tectonic plates meet: the South American plate and the Nazca plate and the Antarctic plate. This triple junction is unusual in that it consists of a mid-ocean ridge, the Chile ridge rise being subducted under the South American plate at the Peru-Chile Trench. In the graphic on the bottom left, it showcases the Chile Ridge, also known as the Chile Rise, as a submarine oceanic ridge formed by the divergent plate boundary between the Nazca Plate and the Antarctic Plate, and it extends from the triple junction of the Nazca Pacific Antarctic Plates to the southern coast of Chile. The Chile Ridge is easily recognizable on the map, as the ridge is divided into several segmented fault zones, which are perpendicular to the ridge segments, showing an orthogonal shape towards the spreading direction, and the total length of the ridge segments are about 550 to 600 kilometers. In the graphic to the left, it showcases a convergent plate boundary that showcases just how seismic of an area Chile is due to its proximity to the stressed Nazca and South American tectonic plates, which are converging at the rate of 80 millimeters per year, one of the fastest rates on Earth. To the west of the Chile, the Nazca plate extends beneath the Pacific Ocean and meets the Pacific plate along a divergent plate boundary called the East Pacific Rise. The southern edge of the Nazca plate adjoins the Antarctic plate along another divergent plate boundary called Chile Rise. So the geological setting describes the land forms. So the geology of Chile is characterized by processes linked to subduction such as volcanism, earthquakes, and orogeny. The subdugation interactions shape four main morph structures of Chile: the Andes, the Intermediate Depression, the Coast Range, and the Peru-Chile Trench off the coast. Since Chile is on an active continental margin, it has many volcanoes, as shown in the image on the bottom right. Almost the entire country is subject to earthquakes arising from strains in the Nazca and Antarctic plates or shallow strike-slip faults. The Chilean Easter Island and Juan Fernandez archipelago are volcanic hotspot islands in the eastward moving Nazca Plate. The geology of the Chilean Antarctic territory has various commonalities with the mainland of Chile. On the top right, I provided a geological map of northern Chile between 25 degrees south and 31 degrees south, indicating the Atacama Fault System in the present-day forearc as based on the maps in Tornos et al., which is on the left, which is on the right, just indicating where the faults are and where La Serena is. So the cause of this geological hazard, the unique triple junction rightmost image is conductive to this formation of several different types of hydrothermal venting. Hydrothermal venting occurs when seawater penetrates the crust or sediments near the axis of an oceanic spreading center, is heated by the underlying magma or molten rock of a chemical reaction and returns to the seafloor as hot or warm, mineral-rich water. Since the Chile rise is spreading at an intermediate rate of about 60 millimeters per year or 2.4 inches per year, the amount of magma beneath the ridge is enough that high-temperature black smoker-type hydrothermal systems with mineral-rich chimneys, left image, are likely to be found approximately every 100 kilometers or 62 miles on the ridge near the triple junction. The geology of the Chile margin also makes the area a prime location for the formation of methane seeps, another primary target of cruise research, and the intermediate water depth of about 800 to 1,000 meters. And I could go on talking about this, but I feel as though I went into in-depth on what the triple junction did, and I kind of just saw how this how bottom simulating reflector, the BSR, showed evidence of this occurrence, and I just thought it was pretty interesting that methane, of all things, were actually forming and could be one of the causes of this hazard. So some takeaways and some future efforts. Chile is actively involved in the UNESCO International Platform for Reducing Earthquake Disaster, which is a platform for basically outreach, and it's engaged in the conceptual shift in which thinking away from post-disaster reaction to pre-disaster reaction. So through its broad mandate and expertise, it's helping countries reduce their vulnerability to natural hazards and build their capacity to cope when disasters through initiatives such as IPRED and the 4 regional tsunami warnings established in Pacific, Caribbean, Indian Ocean, and Northeast Atlantic regions. And I feel as though this is a really important thing to note because a lot of these disasters could be avoided, or more casualties could be avoided earlier if earlier action was taken. And I hope this isn't the only thing that Chileans have at their disposal, and I have provided a few more links at the bottom here to, if you want to look into how you can volunteer for Chile activists, how you can donate. It's all here to indicate just the type of trauma that Chileans have to endure, and since COVID hit, it's just taken a turn for the worse, and they could really use their help. But thank you. That's it.